Here's a question on probability. Two fair dice are thrown. I'm going to want to tell these apart, so I'm going to say one of them is red and one of them is blue. And now we're going to answer some questions about this. What's the probability that the sum of the numbers that you see on the dice actually adds up to 6? So we need to look at all possible outcomes, the sample space, and that's all possible pairs of numbers that you can see. So I'll write this as the set of all A, B, such that A and B range over the set 1, 2, 3, 4, 5, 6. And maybe the first entry is the red one and the second entry is the blue one. And that's a curly bracket, of course. This is all possible outcomes. Now, which of those actually add up to 6? We'll write that down as our event A. So that event is the set of all outcomes which add up to 6. So you can have 1, 5, you could have 2, 4, 3, 3, 4, 2, or 5, 1. And when you think about it, these are the only possibilities that add up to 6. There's 5 of those outcomes compared to 36. Therefore, the probability of event A is the size of A on the size of S, which is going to be 5/36. The size of A over the size of S, which is 5/36. Okay, now we ask, what's the probability that both die show the same number? We still have the same sample space. I've just written it up before again. The set of all possible pairs. So there's 36 elements in this sample space. How many pairs have the same entry? Well, there's just going to be 6. So now the event that both dice, I guess, show the same number is a set, a subset of the sample space. So it's all the pairs with the same entries, 1, 1, 2, 2, and so on. Which obviously has size 6. We'll call this A. And so again, the probability of the event A is just the size of A divided by the size of S. Which in this case is 6/36, and you can cancel that to get a probability of 1/6. And finally, what is the probability that at least one of the two dice shows an even number? It's actually easier to calculate the probability that neither of them are even, which means that they're both odd, and then just subtract that from 1. So for our solution, that's our approach. We first calculate the probability that both the dice show an odd number. Now, rather than look at the state space we had before with 36 entries, let's clump things together depending on whether they're even or odd. And this really just gives 4 possibilities. They're both even, red is even and blue is odd, vice versa, or they're both odd. So the sample space that we consider is the set S with these 4 entries: even, 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 odd, And the next thing to realise is each one of these actually corresponds to the same number of outcomes, the same number of rolls of the dice, because a dice has 3 ways to be odd and 3 ways to be even. So for example, red even and blue odd, there's 9 possible outcomes in the old state space, which means each one of these has 9 outcomes. They're equally likely. So each of these outcomes is equally likely. They each correspond to 9 of the pairs we saw before. So that means since there's 4 outcomes, each one has probability 1/4. And therefore, the probability that both dice are odd is just 1/4. Subtracting this from 1, we see the probability that at least one is even is 3/4. Answering the original question. Precisely 1 minus 1/4, which is 3/4.